For my project, I built a circuit that records the temperature, humidity, and light in the environment around it. I did this so I can measure how much the sun impacts the temperature outside. I've always wondered how much warmer it gets when there's direct sunlight instead of partially blocked sunlight, like if you're hiding under a tree. I could also use this to tell how energy efficient a light bulb is. If a light bulb gives off a lot of heat, it means it's using a lot of energy. You can use this device I've made to test how energy efficient light bulbs are, based on the principle stating that energy can't be created or destroyed, but can only be altered from one form to another. So the energy that goes into the light is either outputted as light energy or as thermal energy, so you're measuring the thermal energy. However, the plan for this project was originally intended to use outside, like if it's sunny outside, see how much higher the temperature is in the sun rather than in the shade. To build this project, I used a light sensor and a DHT11 thermal sensor. The light sensor works by sensing if there is light or no light. If there is light, it will send a 0 through the wire and the buses to get to the CPU, where it will be read by a program, and then it will display a 0 when it gets displayed on the screen. With this picture, you can see that if the light is shined on the light sensor, it will send a 0 through the wires. That way the Raspberry Pi knows there's light. In this picture, you can see that if it's dark, represented by the little black circle on there, the light sensor will send a 1 through the wire into the Raspberry Pi, so that way it knows it's dark. This is a DHT11 thermal sensor. This one works by connecting two smaller sensors, a humidity sensor and a temperature sensor. Since I'm only concerned with the temperature, I'm not going to explain how the humidity sensor works. But for the temperature sensor on it, it's an NTC temperature sensor. NTC stands for negative temperature coefficient. So what that means is that as the temperature goes up, the resistance goes down. So basically with that, how the temperature sensor works is there's like a film on the inside that reacts to temperature differently. So the higher the temperature goes, the sensor will output a different electrical signal to the Pi. So this way, when I run the Python program on the Raspberry Pi, the program gets loaded into the registers in the CPU, and then the CPU will execute that program, and then it will pull those numbers from the sensors and display them. With this picture, I'm showing that if you put a fire in front of the sensor will recognize that it's hot and it'll send a higher signal through the wire. With this picture, you'd see that if something's cold in front of the sensor, it'll throw a lower voltage signal through the wire, meaning that it's cold. This picture shows that if the sun's out, the sensor will put a higher voltage signal through the wire, and the light sensor will send a 0 to the Raspberry Pi, signaling that it's light outside. This picture shows that if the moon's out and it's dark or there's shade, the temperature sensor will throw a lower voltage signal, so it's cold, and the light sensor will put a 1 through the lines. That way the Raspberry Pi knows it's dark outside. This is a clip where I turned on a light on and off to test that my project actually worked. Here you can see, if you type in Python and then the name of your file, it'll run the file, and then it will display what the sensors tell it to display. So for this first one, you can see it's displaying a 0 for the light, saying that there is light, and then it has a temperature and humidity. When I run it again, you can see this time it's displaying 1, saying that it's dark, there is no light, but the temperature stays the same. That's because I did this in my dorm room, so there is no change in temperature. In this part, you can see that the light turned back on since the number went back to a 0 from a 1. This is the Python script I used to get the information to display on the screen. basically you just make a text file that ends in .py for Python, and then you have to import 3 different libraries for this one. So that's sort of the first 3 things, and then the 2 lines after that are gpio.set and then something else. Those ones are just to let the Raspberry Pi know which sensor is coming in on which input. After that, there's a for loop that will display the readings from the temperatures 5 times. That's a 0 to 5. And then in that loop, I have the humidity and temperature equals Adafruit underscore DHT.read. That line calls upon the Adafruit library and has it do its thing. Then the line after that starts with print, that formats the information coming from the sensor and displays it. And the last one, print gpio.input17, that is for the light sensor, and that one displays either a 1 or 0 depending on if it's light outside or dark outside. For the procedures I used for this project, I started with connecting the sensors each individually and then testing each sensor. Like for the light sensor, I wired the circuit positive, negative in the input into the Raspberry Pi, and then I coded the program to get it to display to make sure that sensor works. And then I did the same thing with the humidity sensor to make sure that one also works. And then after I did that and got both of them working, I wired the circuit for both sensors to both be hooked up at the same time, and then modified the program and merged them together so that way it displayed both on the screen when you ran the Python file. I tested this once by putting it in the window to see if the sunlight actually read, and then I also tested it again, as you saw in the video, on my desk with a lamp. When I was trying to build this project, I ran into a few problems. One of the problems I was having was sensors not working. For example, one of the first sensors I tried was a thermal sensor, but it had analog output instead of digital. And then I found out that Raspberry Pis only are able to accept digital input instead of analog, so that was a problem. I had that same problem with a light sensor, but I figured that one out too. And then I had a different thermal sensor, which I realized you had to have digital and analog input, so it wouldn't work with the Raspberry Pi. So to solve these ones, basically I just looked and saw what the problem could have been, and they were both fairly simple, that I didn't have the right type of input on the Raspberry Pi. Other problems I had was my programs that I was trying to program wouldn't work, and that was due largely to not knowing Python or really how the GPIO pins work on the Raspberry Pi. So I used tutorials and I kept on switching to different ones until I found ones that worked. And then I also had issues with the Python script when I tried to merge them because I didn't fully understand it. So I was trying to guess which thing goes where, but eventually I figured it out. I'd say the biggest problem I had was since I had to use a digital input for the light sensor, it didn't give me a range like how bright it was outside like an analog light sensor would work. This one just displayed either true or false. So the problem I had with that one was even if it was in the shade, it would still say it's light outside because it wasn't completely dark. So I had a hard time trying to adjust it to where it would get that it's darker and not lighter, to adjust the line where it would say true or false. With this project, I learned that analog input is much more efficient than digital input, and that digital light sensors aren't as useful as analog ones since they can't distinguish different levels of light. It's just if it's light outside or if it's not light outside. And then I also learned that the Raspberry Pi also accepts digital input, so it's not as useful for custom circuit building as an Arduino. And I also learned that in the future, if I were to redo this project, I'd buy an analog to digital converter, so that way I can still use my light sensors and temperature sensors to get more accurate readings. By doing this project, I learned you have to download different files, and I also learned how to use the command console to download some things and how to get Python files to run. I also learned how to make Python files using the command console,